and I'm giving name head1 and head2 for those pointers, right? Say for example, this is this polynomial 1 will be pointed by head 1 and this polynomial 2 will be pointed by head 2. Fine. And the resultant polynomial which we want will be pointed by head only. Okay, fine. This is head 1, head 2 and this is head. So the head 1 will be pointing to the first term and head 2 will also point to the first term. These terms are not yet created. So initially head will be pointing to empty, right? Head is pointing to empty. And as we move further, we will get the resultant terms in the polynomial. Okay. So first of all, if you see, we have set the pointer and these pointers are pointing to the first term of both the polynomials, right? Then that means head 1 is pointing to 5x4 and head 2 is pointing to, and head is pointing to none initially. So what we want to do, we need to check the exponent of both the terms, right? We need to check the exponents of both the terms. So here exponent of the first term is 4 of polynomial 1 and exponent of first term is 5 of polynomial. So they are not equal, right? So if they are not equal, we cannot add them, right? We cannot add them directly. We cannot add coefficients, right? Because the exponent part is not equal. So what should be there? The term which is containing highest exponent should be copied as it is in the result, right? The term which is containing highest exponent will be copied as it is. But instead of 5, for example, if it is 4 here, right? If it would be a 4, then what we have to do? We have to add the coefficient for these two terms, right? So if they are equal, right? If they are equal, I am considering the case for equal first here. Then what I will do? I need to create a new node with sum of coefficient of both terms and exponent part. Exponent part will remain same. Suppose for example, if just a minute, just a minute. Sorry for the interruption. Okay, so if both the exponent parts are same, then what we need to do? Are someone waiting outside? No one, na? Then we need to create a new node with coefficient will be sum of the coefficient of both term and the exponent part will remain same. For example, if it is 2x raised to 4 and 5x raised to 4, then the coefficient is 2 and 5. So the coefficient will become 7 and exponent part will remain 4 as it is. So if both the terms pointed by head 1 and head 2 are equal, then we will creating a new node, and in that case, if this is the first node of the resultant polynomial, because initially our head is none, right? Then we need to set the head to point to this first node, right? That means what we will do, our head will point to this newly created node, right? Head will point to this node. And if this is not the first node, for example, if the resultant node is like this, already we have processed 3 terms, right? So this is pointing to this and this is pointing to none. Okay, so we need to traverse first. So from head, we will traverse to this first, then to second, and then to third. And this third node will be then pointing to the new node, right? So that we have to do. And once this is done, what will be the next step? To move the pointer of head 1 and head 2 to next term. What is our next term? Our next term is then this one, Head 1 will point to this and head 2 will point to this if these two are same, right? If this is 4 and this is 4, then only, yeah? Otherwise not. Now, what was our case? Our case is what? That the exponent of P1 was 4, right? Exponent of P1 was 4 and P2 was 5. That means head 2 exponent is greater. Means term of polynomial 2 is greater than first one, right? So if the case is different, for example, if it is like this 5 and 4, then what is the case? Head 1 is greater than head 2, right? If it would be 5 and 4, I am taking one by one case. Okay, first I am taking for equality, then I am taking head 1 is greater, and then I will take head 2 is greater. So I am assuming here that the exponent part of the first term is 5 and that of second is 4. So head 1 term is greater. Okay. So else if the head 1 polynomial, first polynomial, exponent of first polynomial is greater than the exponent of second polynomial, then what we need to do? We need to copy the first, the term of polynomial 1, which was the term, for example, the term is suppose 5x raised to 4. Okay, what I will do, I will assume it as 5x raised to 5 and I will assume here as 8x raised to 4, for example. I can assume anything for explanation of this algorithm. Right? So what I am assuming that the first term is say 5x raised to 4 and the next term is say 3x raised to cube, for example, of polynomial 1, and head is pointing to this 5x4. Then what should happen? We will create a new node with coefficient 5 and exponent 4, right? With coefficient 5 and exponent 4, and this new node will be a part of the resultant polynomial, right? Once again, if this is the first term, the head will point to this new node, and if this is not the first term, then head will traverse to the last term, and then next node will point to this new node, right? The same thing. If the resultant is empty, then the newly created node will be pointed by head. Otherwise, what we need to do? We need to traverse to the last node of the resultant polynomial, and the last node will then point to the new node. Okay. And one more thing, what we have to do? We need to move to the second point, the second term of P1, because head 1 was pointing to this 5x4. Now it should point to 3x2. So what will be our steps? If this is the first node of the resultant polynomial, then set the head to point to the newly created node, as I told you. Else, we need to traverse the resultant polynomial and set the next field of last node to the newly created node. Okay? And then move the head 1 pointer to point to the next term of polynomial 1. Right? If the exponent term of first polynomial is greater than the exponent term of second polynomial, then this thing. And the third case is what? That exponent term of polynomial first polynomial is less than. This is if the exponent term of first polynomial head 1 is less than the exponent term of second polynomial head 2, right? Then again we will create a similar node which is pointed by head 2. So new node will be creating once again with the coefficient and exponent of the term of second polynomial, right? Term of polynomial 2. That we will do. Means same procedure which we have done for the previous one, because here the head 1 polynomial, the first polynomial term of exponent of term of first polynomial was greater, so we have done with respect to head 1. Else we will do the same thing with respect to head 2. That means we will copy the term of the polynomial pointed by P2 and in the resultant one, and we will move the head 2 to the next pointer, right? So the same thing we will do. If this is the first node of the resultant polynomial, then set the head to the newly created node, else traverse and move the head to pointer to the next term of polynomial 2, right? Three cases are there. One is equal, other is first one is greater, other one is the second one is greater. So we have seen all the three cases. In any of the case, we have to create a new node. Only thing is that when both are equal, we have to add the coefficient of the two terms. But if first one is greater, then we will copy the term of first pointed by first and add it into the resultant. Else we will copy the term pointed by head 2 and add it into the resultant. Fine. समझ में आया इतना चीज? Hello.
Yes, sir.
Yeah. Now, as long as suppose this is your P1, P1 is containing say 4 terms, and P2 is containing say 3 terms, right? What may happen? The P2 pointer may reach last, है ना? At some stage, P2 will reach to the last edge. That means there are no terms left now in P2, but only and P1 is also only one term is left in P1. We have considered 3 terms of P1 and 3 terms of P2, and accordingly we have created the result, right? Created the result. Now only one term is remaining in P1. P2 is over. So what we will do? We will repeat the above steps till both pointers are pointing to the corresponding terms of their polynomials. जब तक P1 भी पॉइंट कर रहा है, P2 भी पॉइंट कर रहा है, तब तक ही हम 3 to 6 रिपीट करेंगे. बट जैसे ही दोनों में से कोई एक खत्म हो जाएगा, क्योंकि इसलिए मैंने यहाँ पे लिखा है कोड, जब तक दोनों में से एक खत्म हो जाता है तब तक हम ये रिपीट करते रहेंगे. वी विल रिपीट द स्टेप्स टिल both are pointing to some terms in their polynomial. But if one of the polynomial is over, then we will come out of this loop. Now what may happen, right? Either P1 may be over or P2 may be over. दोनों में से क्या होगा? या तो P1 खत्म हो जाएगा या P2 खत्म हो जाएगा. So what we need to check? We need to check if all the terms of polynomial 1 are referred. मतलब हमने उसको यूज कर लिया रिजल्टेंट में. It means what does it means? That remaining terms of polynomial 2 are to be copied in the resultant polynomial, है ना? अगर head 1 खत्म हो गया है तो जितने भी टर्म्स हेड 2 पॉइंट कर रहा है उसको हमको रिजल्टेंट पॉलिनोमियल में कॉपी करना है, राइट? या फिर अगर हेड 2 के सारे टर्म्स हमने कंसीडर कर लिए हैं, हेड 2 के सारे कंसीडर कर लिए, मतलब बचे किसके हैं? हेड 1 के बचे, मतलब पॉलिनोमियल 1 के बचे. सो ऑल द टर्म्स ऑफ पॉलिनोमियल 1 आर टू बी कॉपीड इन द रिजल्टेंट पॉलिनोमियल एज इट इज, राइट? समझे क्या? Any doubt? Hello? 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 No, sir. Clear. Okay. Anyone is having any doubt? Because see, it's very simple that we have to. We'll just tell you in nutshell once again. Here suppose these are the terms 5x4 plus 7x cube plus 2x, and here also I will guess a 7x4 plus 5x cube plus 3x. Now what I have done here, I have put the exponent part same all the time. So now head 1 is pointing to, I will write h1, suppose h1 is pointing to this and h2 is pointing to this. Both are equal. So what will happen? 12x raised to 4, this node will be created and head 2 will point to next, head 1 will also point to next. Now both are pointing to this second term. Again exponent part are same, so it will become plus 12x cube, and again head 1 will point to this and head 2 will point to this. So once again now 2x 3x, so exponent part is same, so it will become pi x. Now head 1 is pointing to last, head 2 is also pointing to last. So your work is over, right? If this is the case, this is the most favorable case because both are pointing to the last node. So your algorithm is over and whatever resultant, you will get resultant here. But if the case is like this, 5x raised to 4 plus 7x cube plus 2, and here you are having 7x raised to 5 plus 8x raised to 2, for example. These are the only two terms, two polynomials. So head 1 is pointing to this first one, head 2 is pointing to this. Here this is 4, this is 5. So we won't consider this, we will consider this term. So this term will be copied in the answer and this pointer will move to next. Till then head 1 is pointing to the first only because we have moved only head 2 to 8x square. Now what is happening here? It is 4, here it is 2. So this one is greater. So we will consider this term in the result 5x raised to 4 and head 2 will point to this now 7x cube. And head 1 is pointing to 7x cube and head 2 will remain to 8x square. So again 3 and 2. So 3 is greater. So again we will copy this term in the answer 7x cube and we will point to next term here. Now here 2x raised to 0 it is actually. So here it is 2 and here it is 0. So this one is greater. So this will be copied in the answer 8x square and it will point to next. So now head 2 is over but head 1 is remaining. So this remaining term will be copied as it is in the answer 2x raised to 0 will be remaining as it is copied. Got it?
Yes, sir.
Yes,
Yeah.
sir.
So now we will see the code. This was the algorithm and now we will see code of the algorithm. So yesterday I told you about this class node in which we are having a constructor, coefficient part and exponent part is stored here. We have seen the insert at beginning and insert at end, and now we are about to see the add nodes. So what we need to pass? We need to pass the starting address of polynomial 1 and starting address of polynomial 2. I am storing it in head 1 and head 2, right? And this self is the resultant. This self is the resultant answer, third polynomial. Okay. So our first condition is what? While head 1 is not null and head 2 is not null. दोनों अगर point कर रहे किसी term को तो हम इस while loop में रहेंगे. Okay. So this is the first condition. If head 1 expo is equal to head 2 expo, we are creating a new node here. How we are creating a new node? By adding the coefficient of head 1 and head 2. We are creating a new node, right? And self dot head is not none means what? If the resultant is empty. If the resultant is empty, then we are pointing the head to this newly created node and we are going to next. Head 1 will point to head 1 dot next and head 2 will point to head 2 dot next, right? Else what we need to do? We need to traverse to the last node of the resultant polynomial. So last is equal to self dot head and while last dot next, last is equal to last dot next. With the help of this code, we are traversing to the last node of the resultant. Once we reach there, then we are storing the new node in the next field of the last node. हम क्या कर रहे हैं? जो नया नोड हमने बनाया है उसको हम इसमें स्टोर कर रहे हैं, राइट? लास्ट में, रिजल्टेंट के लास्ट में. एंड अगेन वी आर pointing to the head 1 and head 2 the next. We can reduce this code here because these two code are copying here. Same thing is happening here, so we can reduce this code, right? Now if the exponent parts are not equal, it will come here. Else if, what may be the condition? That head 1 exponent may be greater than head 2 exponent. So if head 1 exponent is greater than head 2 exponent, what we need to do? We need to copy the node of head 1 pointer, right? So we are creating a new node with head 1 coefficient and head 1 exponent, right? And once again checking if the resultant is empty, we are assigning the newly created node to the head of the first head of the resultant resultant polynomial, and we are pointing head 1 to the next node. Head 1 is equal to head 1 next. That means head 1 is pointing to the next term of polynomial 1, right? And if this is not empty, so once again we are going to the last node of the resultant, and then last dot next is pointed to new node, and head 1 is pointing to head 1 dot next. So this is the code in which we are copying the term of polynomial 1 in the result, because head 1 exponent is greater than head 2 exponent. And the third case will be what? Else means what? Head 2 will be greater than head 1. So if head 2 is greater than head 1, then head 2 coefficient and head 2 exponent will be there in the new node. So new node is created with head 2 coefficient and head 2 exponent part, and the same thing is repeated here once again. What is the thing which is repeated? That we are copying the head 2 node in the resultant, right? So this is the case when head 1 and head 2 both are pointing to some node, right? Both are pointing to some node. This is the loop. यहाँ तक क्या हो रहा है? जब तक हेड 1 और हेड 2 दोनों पॉइंट कर रहे हैं तब तक. बट अगर हेड 1 या हेड 2 में से दोनों भी अगर नन हो जाता है तो हम इस व्हाइल लूप में से बाहर आ जाएंगे. हम आएंगे यहाँ पर, आएंगे यहाँ पर, सॉरी, हम कहाँ आएंगे? अब दो केसेस है, या तो पॉलिनोमियल 1 खत्म हो सकता है या पॉलिनोमियल 2 खत्म होगा. सो इफ हेड 1 इज नन मींस व्हाट? वी हैव रेफर्ड ऑल द टर्म्स ऑफ पॉलिनोमियल 1. तो उस केस में हम क्या करेंगे? फिर से लास्ट नोड में चले जाएंगे रिजल्टेंट के, और हेड 2 के सारे टर्म्स कॉपी करेंगे, क्योंकि हेड 1 खत्म हो गया है. इफ हेड 1 इज नन मींस व्हाट? देयर आर टर्म्स रिमेनिंग इन पॉलिनोमियल 2 व्हिच इज पॉइंटेड बाय हेड 2. सो व्हाइल हेड 2 इज नॉट नन, जब तक हेड 2 नन नहीं रहेगा तब तक क्या करेंगे? सारे हेड 2 को हम कॉपी करते जाएंगे रिजल्टेंट में. सो लास्ट डॉट नेक्स्ट इज इक्वल टू हेड 2 एंड हेड इज इक्वल टू हेड 2 डॉट नेक्स्ट. लास्ट डॉट नेक्स्ट इज इक्वल टू हेड 2, और इसमें क्या आएगा? एक और चीज आएगी, कोई बता सकता है क्या आएगा? लास्ट डॉट नेक्स्ट जगह क्या आएगा? लास्ट डॉट नेक्स्ट इज इक्वल टू हेड 2 एंड क्या आएगा यहाँ पर? लास्ट इज इक्वल टू लास्ट डॉट नेक्स्ट, है ना? क्योंकि लास्ट को भी अपडेट करना पड़ेगा ना हमको, राइट? लास्ट को भी हमको अपडेट करना पड़ेगा. ये समझ में आया कि क्यों लिखा मैंने? जैसे मैं हेड 2 को अपडेट कर रहा हूँ, वैसे लास्ट मतलब रिजल्टेंट का ही है, इसको भी मुझे अपडेट करना पड़ेगा. सेम थिंग यहाँ पर होगा. एल्स इफ हेड 2 इज नन, मतलब हेड 2 पॉलिनोमियल 2 के सारे टर्म्स अगर ओवर हो गए, खत्म हो गए, तो हेड 1 के जितने भी बचेंगे उतने मुझे यहाँ पे लाने पड़ेंगे. सो लास्ट इज इक्वल टू लास्ट डॉट नेक्स्ट. ठीक है, फिटिंग रन करके देखते हैं. See, 5x raised to 4, 3x cube minus 2x square plus 1x raised to 0 minus 8x raised to 5. तो यहाँ पर minus 8x raised to 5 आ गया. फिर ये x raised to 4 है और ये भी x raised to 4 है, बट ये 5 एंड minus 4 है, तो 5 minus 4 1x raised to 4 आ गया यहाँ पर, राइट? फिर 3x cube एज इट इज आ जाएगा, 2x square एज इट इज आ जाएगा, फिर 12x raised to 1 एज इट इज आ जाएगा, और 1x raised to 0 एज इट इज आ जाएगा, राइट? तो we have seen the implementation of our algorithm. What is our algorithm? That you have to scan all the terms, corresponding terms pointed by head 1 and head 2, right? A loop. And what is the cases we will going to check in this? At exponent part of both the terms, corresponding terms of polynomial 1 and 2 will compare. If they are equal, we will add the coefficient and move ahead to next term in polynomial 1 and polynomial 2, right? And if the exponent part of P1 is greater than exponent part of P2, then we will copy the term of P1 into the answer and move ahead P1. Else, if the exponent of P2 is greater, then we will copy the term of P2 and into the result and move ahead in P2. This thing we will repeat till both are pointing to some terms in both polynomials. But if one of the polynomial is exhausted or over, then we will come out of that loop and then we will check which one was over. If head 1 is over, that means P1 is over, we have to copy all the terms of P2. And if P2 is over, we have to copy all the terms of P1. So that we are doing here. P1 is copied, here P2 is copied, right? And simply here invoking this is the list list3 dot add node, list head 1, list 1 dot head and list 2 dot head. We are passing the 2 pointers to the add node function P1 and P2, right? So any issue in this? Yes, any issue? Anyone else? Got it? बोल भी सकते हो, केवल चैट बॉक्स में ही लिख रहे हैं. माइक बंद है क्या आप लोगों का? Okay, so we have covered this topic of polynomial, right? Polynomial representation and addition. Now what is remaining? How to implement the doubly linked list and the operation of that, right? In doubly linked list, what is the advantage which we are getting? That we are having the pointer for previous as well as the next. In singly linked list, we are having only the next pointer. That means we can move only in one direction. But in doubly linked list, you are having 2 pointers, one to the previous and one to the next one. So that is the only advantage of doubly linked list, right? So because you are having additional information in doubly linked list, the code becomes somewhat simpler as compared to singly linked list, right? Because if you are in any of the intermediate node, you can traverse in both directions. That is the only advantage of doubly linked list. Otherwise, as far as implementation part is concerned, it is almost same as that of singly linked list, right? So I have uploaded this code also yesterday, doubly linked list. Yes, I have uploaded now.
Yes, sir.
Yeah. So have you gone through that code?
Yes, sir.
So is there any issue in that? See, I will run this code first, right? So what is happening here? Initially, the linked list is empty. Then I am inserting to empty list 10, right? So my element is 10. Then what I am doing? I am inserting at end of list 20. So my list becomes 10 and 20. Then I am inserting 30. So my list becomes 10, 20, 30. Then I am inserting at end of list 40. So my list becomes 10, 20, 30, 40. And finally I am inserting 50. So my list is becoming 10, 20, 30, 40, 50. Now what I am doing here, I am deleting the first element. These are the only outputs. I have written code for this. These are the outputs only. So when I delete the first element, what is happening? 10 is removed. So you are seeing only 20, 30, 40, 50, right? And if you are deleting last element, so you are seeing only 20, 30 and 40. So 50 is removed, right? So you can perform any operation. You can insert to the empty list. You can insert at the end. Even you can insert at the beginning. You can delete the first element. You can delete the last element. If you know the address of any of the node, you can delete any node in between also. There is no issue for that. Okay. So this was just a snapshot of the output of the program which is given to you yesterday, right? So any doubt in basic operations, how to create a node? Is there any doubt in that? Anyone is having any doubt for creating the node? Because this is the code which is responsible for creating the new node. Any doubt in this part of code? Can anyone tell me what is this underscore underscore init underscore underscore? What is this function means?
Constructor also.
Yeah, this is constructor, right? So with the help of constructor, we are creating a new node and assigning the data to that. And when the new node is created, what you have to keep in mind, the next and previous field of the newly created node should be none, because that is the newly created node. It won't have any link. Then after creating the node, we have to move that node, or we have to make a part of a linked list. The node should be a part of linked list, and while doing that, then we will manipulate next and previous field. कहाँ पे उसको डाल रहे, accordingly हम next और previous field को manipulate करेंगे, right? So I think there is no issue in creation of the new node. Now next part is what? How to create a doubly linked list. So for that purpose, we will have a class doubly linked list, and initially the constructor, when the object of doubly linked list will be created, it will be pointing to none, because no nodes are created yet. Only you have created a empty linked list. So self.head will point to none, right? Now the very first thing, the function here is insert to empty list. That means the list is empty, you are knowing that, and you are trying to add one node in that linked list, right? So what I am doing here, I am because we have to ensure whether the list is empty or not. How we will ensure? If self.head is none, it means the linked list is empty, because head is pointing to none. Because in constructor, when the object was created, the constructor, we have said self.head is none. Okay. So if self.head is none, new node is equal to new node. Okay, we are creating a new node, right? And we are assigning the address of the new node to the header. So what will happen here? क्या होगा यहाँ पर? एक मिनट, मैं जस्ट एक क्रिएट करता हूँ. So when you will create a new node, now this is having two links, previous and next. So this is your head. So your head is pointing to this field, this node, right? Head is pointing to this node where you are having none, and here is also none. That means it is not pointing, the previous field is also pointing to none, and next field is also pointing to none. That means this is the only node in the linked list. Okay, this is the only node in the linked list. Okay, but if head is not none, then what we are doing? We are saying list is not empty. So this is the function responsible for entering a single node when the list is empty. That's all. Now, if you want to insert the element at the end, so the function for that is insert and end, and you will pass data. So once again, what may happen, that without calling insert to empty list, you may call insert at end, right? So what may happen? Possibility that head is pointing to none, right? So if head is pointing to none, what we need to do? If head is pointing to none, then again we have to create a new node, right? The same thing which we have done in insert to empty list. So again, if head is none, we are creating a new node and assigning the address of new node to the head. But if the list is not empty, right? That means you are having some intermediate nodes in between. So these are the nodes, and this field initially it will be none, and next is pointing here, previous is pointing here, next is pointing here, this previous is pointing here, and this next is none, right? So you want to insert at end. Here you want to insert a new node. So you will create a new node here, and you have to reach to this last node. So how you will reach? By traversing. कैसे reach करोगे आप यहाँ पर? By traversing. So you will first point to this next. From next you will go here. From next you will go here. And when you found that this is none, you will stop here. And then this last node, next field, will be equal to new node, right? And the new node previous, right? What new node previous will be what? Last का जो previous field है ना? Last का जो previous field है, sorry, last का कौन सा एड्रेस आएगा यहाँ पर? यहाँ पर मुझे इसका एड्रेस डालना है ना, लास्ट का. तो लास्ट का प्रीवियस का नेक्स्ट है ना, ये लास्ट था आपका, इसके प्रीवियस में ये एड्रेस है और इसके नेक्स्ट में ये एड्रेस है. तो हम डायरेक्टली क्या लिख सकते हैं? न्यू नोड डॉट प्रीवियस इज इक्वल टू लास्ट, है ना. डायरेक्टली लास्ट का एड्रेस हम स्टोर कर सकते हैं. तो ये नए नोड के प्रीवियस में लास्ट नोड आएगा और लास्ट के नेक्स्ट में न्यू नोड आएगा. देखते हैं. देख, लास्ट के नेक्स्ट में नया नोड आएगा और प्रीवियस में लास्ट आ जाएगा, राइट. ये ट्रैवर्सल पार्ट है. ये पार्ट हर कोड में देखा है हमने, हाउ टू ट्रैवर्स. वी आर storing the starting address of the list in the last, and while last dot next is not none, we are updating the last field. So we are creating a new node, and then we are adding that node in the last of the list by storing the address of new node in last dot next, and the new node previous will be last, right. So in this way we are inserting at the end, right. Any problem in this? Now if you want to delete at start, so suppose these are the nodes, 2-3 nodes are there, and this is the first node, this is the second node, this is the third node. Your head is pointing to the first node, right. Here the previous is none, and this is next field, right. Next is pointing to 2. Okay, so we want to delete this node, right. So what we need to do, we will need to store the address of the second node in this head. So what will be the head? Head will be equal to self dot head will be equal to self dot head dot next, है ना. self dot head किसको पॉइंट कर रहा है? 1 को. 1 का जो नेक्स्ट है वो हेड में आ जाना चाहिए, राइट. और ये जो हेड का जो प्रीवियस है, मतलब अभी सेल्फ डॉट हेड किसको पॉइंट कर रहा है? 2 को पॉइंट कर रहा है. तो सेल्फ डॉट हेड डॉट प्रीवियस, ये क्या हो जाएगा? नन, है ना. दिस बिकॉज दिस इज नॉट पॉइंटिंग टू दिस नाउ, so automatically your head is pointing to 2 and your 2 is pointing to none, so 1 is removed. So this is the code which is responsible for removing the item first from the beginning. So see here, self dot head is equal to, just a minute, hello. Right. So delete at start means what? Self dot head is equal to self dot head dot next, and self dot head dot previous is equal to none. That we have to do. We have done here same thing. Self.head is equal to self.head.next and self.head.previous is equal to null. This we have done. So in this way we are deleting the node at the starting, right? So you can read this and you can understand this by your own, right? Because I have explained these three functions. The fourth function should be understood by you, right? And this is the display code, right? Already we have seen the display of single linked list also, and any linked list we have done the display, right? So in this display we are simply displaying the data here. That's all. Okay. So any issue? Yes. Is there any issue? Please.
No, sir.
Hello. Yes. Any issue? Anyone? Otherwise, I will just talk on the one more topic of doubly linked list. That is the application of doubly linked list. Right? Are you able to hear me?
Yes, sir.
Yes. So, any issue in that?
No, sir.
Okay, fine. So let us see applications. One application we have seen of single linked list, that is in polynomial addition. Right? Now, as far as doubly linked list is concerned, whenever in any application, whenever you want to move front or back, right, there are two options. See here also, if you are able to see my screen, I have put my cursor on this, click to go back, hold to see history, right? Are you able to see this message? Yes.
Yes, sir.
Yeah, and this is the forward pointer, this is backward pointer, and this is forward pointer on your address bar to go to previous web page or to go to the next web page, right? If you have seen first, second, third, fourth page, and now if you are at fourth, you can go to third, second, first. Again, you can go to second, third, fourth. If you are at second, you can go to first, or you can go to third page with the help of these two arrows. Here you can see the arrows are there, right? Okay. So with the help of these arrows, you can navigate in between the web pages which you have visited. So in such application, doubly linked list will be used. So doubly linked list means what? It will be pointing to different applications. I will show you here. So this is your application one, right? Or page one, web page one. This is your web page two. This is your web page three, right? So you will have a linked list, right? This is the first node of the linked list, doubly linked list I'm saying, second node and third node. So this first is pointing to second and the second is pointing to first. Once again, second is pointing to third and third is pointing to second. Right? So when you are at web page 1, your previous arrow will be disabled, okay, because the previous field is none. But the next arrow is enabled. When you are going to page 2, your previous and next both arrow will be enabled. So when you click on this, what will happen? You will move to this first page, and here the information of that application is stored, right, in the data field. So here the data field will be much bigger, right? The data field will be much bigger because it has to store the information of that application. Okay. So not always one item or two items will be there in doubly linked list data part. It will be having several K also, several kilobyte also may be the information, because that much information may be required about that application. So in any application, wherever you want to navigate from first application to second application, even in operating system, right? Even in operating system where your processes are running, right? Your process P1, P2, P3 is running. So you may want to shuffle between these processes, right? So you will go from first to second, or from second to third. You may you may need to go to from third to second or second to one. So in such cases, OS use doubly linked list, right? In certain cases, say in Word, right? I will show you the example of Word also. Right. Now this is the Word. Here if you see, the undo is there and here redo is there, right? Undo and redo button. I think you know the undo and redo button in the Word Star or the Word, MS Word, right? So undo and redo. This is also an application of doubly linked list. So like that, there are many applications wherever you want to navigate from in between the processes or in between the tasks, or in you want to do some undo or redo type of operations. In that case, the doubly linked list is used, right? If suppose, for example, if suppose these are the nodes of doubly linked list, right? So this is pointing to this next field. This is pointing to this. If the last node is pointing to the first node, then this type of linked list becomes circular linked list, right? This type of linked list becomes circular linked list. What was happening so far? The linked list was not circular. It was terminating at some point. The first going to second, second going to third, third going to fourth, and it was terminating. Or if you are going to first, sorry, from fourth to third, third to second, second to first, it is terminating here. But if the last one is pointing, the next field of this is pointing to this, and the previous field of this is pointing to this node, then it will never terminate. It will be in a loop. So it will go to from first to second, second to third, third to fourth, and from fourth back to first, second, third, fourth, like this. So first, second, third, fourth, first, second, third, fourth, or it can be 4, 3, 2, 1, 4, 3, 2, 1, like this. So OS also make use of this circular linked list whenever it wants to run different processes from P1 to Pn. So there will be n number of nodes and they will form a circular linked list, and a time slot is given to each and every process. So when the time slot of P1 is over, it will move to P2 process with the help of the second node, because linked list will point to the second node of which is for this process. For P2 there will be one node, for P3 there will be another node. Like this, for every process there will be one node in the doubly linked list, and that node will contain the information about that process, right? This data area will contain the information about this process, right? So with the help of these kind of doubly linked list, OS can assign a time slot to different processes, and you may feel that all the processes are running at same time, right? So any issue in this? Yes. So I will take attendance. बिल्कुल बोलना है आज की तारीख 26
Yes, sir. Ready, sir.
या 1 2 3 8 9 10 1 2 3 8 9 10 11 12 13 15 16 18 19 20 24 26 29 30 33 37 38 40 42 43 B division 2 3 4 6 7 2 3 4 6 7 8 10 16 17 10 15 17 20 21 20. Fine. Okay. So we'll meet tomorrow at 9:15, and we will just finish up the unit of doubly linked and singly linked list. If any questions are there, I will solve those questions, and that's all. Right? Thank you.
Thank you, sir.
Thank you.
Thank you, sir.